without further ado, would you all please join me in welcoming Bruno to give his talk?
Right, so this talk is actually prepared based on real concrete experiences of taking OpenStack since Diablo, I imagine, when we start playing with it, to what actually is a public cloud based in New Zealand. And our public cloud is called the Catalyst Cloud, as you would probably expect. So I'm fortunate enough to work for a company that does only open source software, right? And what that means is that I'm not here to sell you a product, so I don't have to make things look good. And that's, by the way, if you were in the Oracle presentation, that's the letter from our lawyers now. So the first question I always get when people come to this sort of presentations is, how much will it cost, right? And then some people leave the room. Not because it will cost much, but probably because that's all they were interested in. So here's the information up front there. It turns out that if you're doing a minimum production OpenStack deployment, and by production I mean you want high availability. You want to make sure that if you lose a node, you can come up, you can recover from that without impacting your customers. It's probably going to cost you about $150,000 US dollars to come up with that hardware, right? So about $100,000 for the production hardware, for the production cluster, and another 50 maybe for pre-production. And yes, you need pre-production. If you're doing this seriously, you will need pre-production. You will need to rehearse your rolling upgrades in an environment that resembles production, right? So consider that in your budget from day one. It doesn't cost much. You can go maybe second-hand hardware for your pre-production, right? But I'm giving you a new kit here. The second thing is you probably need either 2 to 3 people per month to run it yourself, or a service provider to manage it remotely for you. Most service providers, I talk to many of them, I know many of them, would probably charge you something like $10,000 per month for an initial cluster, right? And it will grow from there, of course. So there is a point where, in the beginning, it's probably cheaper to have someone running this for you, but then it gets to a point where you should have your own people. And of course, if this is strategic for you, if this is your core business, then you should have people from the beginning. And if you cannot afford having competent people from the beginning, reconsider your business. Now, selecting your hardware. The next question is, what hardware should I run OpenStack on, right? Let's start with the network hardware, and I think it's really fortunate that this presentation comes straight after Cumulus. Typically, you would have 2 10 gig switches on the top of your rack, right? And then to start, you'll probably have 2 40 gig switches as your spine. You may want to have your management network separate, so you may have 2 1 gig switches for your management network. But more importantly, you do need your switch for pre-production. Now, these 2 switches, the spine and the management network, you probably don't need on day one. You can probably overload a bit these switches here and use them for other things until you actually need to scale out. But the important thing is plan what your network will look like once you go above a rack or a few racks, so you know how you're going to scale and take the next steps, right? If you don't need high availability, you can probably cut some things here. The other thing is features required. Well, you're probably looking at switches that can do VLAN, VXLAN, MLAG, and I would hope BGP with equal cost multipath after you've seen the Cumulus presentation. Now, I would definitely tell you, forget Cisco, Juniper, Arista, use open source switches. And the reason I say that is because there is now very good open hardware available for switches. If you follow the Open Compute project and other open network initiatives, you know that there is generic white label hardware for switches. But you also have now operating systems for switches that are open source. And if you can run open source in your whole stack, why not? Why the vendor lock-in? And also, by the way, the numbers do stack up better. Now, I would definitely say avoid using vendor-specific neutron providers and go with OpenVSwitch or an abstraction layer that allows you to change vendors. Things in the network space are changing rapidly. And I bet that you will change your hardware provider and what you're doing in less than 3 years. So you know, you will be tempted by network providers. Hey, if you use my neutron provider, you can do this cool thing here, and I give you this amazing graph that allows you to see the capacity and troubleshoot the performance. That's the bait, just to be honest. You know, once you're locked in, it's really hard to move on from that. So I would suggest make sure you have an abstraction layer and you can change network vendors when you desire, right? Server specs. You're looking for a controller node. By the way, before I say that, before I go there, to start with, you're probably looking at 4 types of nodes, and I'll explain why later. But you have controller, compute, block storage, and object storage. When you're growing and when you need more, you know, better service levels, you probably have network nodes as well. But let's start with the 4. So controller nodes, you're probably looking at 12 to 16 cores, 64 to 128 gigs of RAM, 400 gigs of SSD storage. The trick here is you have, you know, your MySQL database, probably in the beginning your Mongo database for Ceilometer on your control plane. There's a lot of data being generated. Some of those queries are not super efficient, so having SSD there will definitely help, right? You also need a decent amount of network connectivity on your controller nodes, especially if they are being initially overloaded as network nodes as well, where all your routing is going on. Then compute. Nowadays, you can easily have, you know, servers with 44 cores or more in one unit, but you can start as low as 12 cores. I would say give it a decent chunk of RAM. Nowadays, our servers at Catalyst will have 44 cores and 768 gigs of RAM. But you know, you can get something smaller. That's all good. The important part is the more CPUs and RAM, the better. But there is a sweet spot there, right? You need to look at, you know, the state of CPUs nowadays, the state of RAM nowadays, find that sweet spot. You know, typically the high-end Xeons with a lot of cores, you'll notice that the prices start getting more expensive there. And the other thing is also consider your failure domain. In the beginning, starting with machines that are too big, when you have one of those servers failing, you have a bunch of customers, a bunch of virtual machines that have been impacted, right? So in the beginning, I would suggest start small and with more nodes. And as you get to a point where you have some scale, then start pushing the, you know, high density nodes. Block storage. I'll share a nice tip with you guys. We have found that if you, I imagine most of you are considering doing Ceph for your block storage solution. If you're not, you know, reconsider, I would suggest. We have found that if you put a single PCIe SSD card on that server with 400 gigs, say, you could use that PCIe SSD as the journal cache for all the hard drives on that server. And I'm assuming you're doing something like 12 spinning drives per server, right? And then your hard drives will have something between 1 to 6 terabytes, depending on what kind of performance levels you're trying to achieve. With Ceph, of course, it's possible to go denser, of course, but with block storage, you're trying to balance the performance of your block storage nodes, right? You're aiming for something like under 30 milliseconds of latency or 10 milliseconds of latency for every I/O operation. Whereas with block storage, well, you can do 300 milliseconds, 500 milliseconds per operation. So you can actually put a lot of hard drives on those servers. And I would suggest you looking at servers, you know, those designs from Backblaze, or is that how you say it? Backblaze? Backblaze. The backup guys, their chassis design became really popular. You get vendors nowadays like Supermicro, Dell, mimicking their designs. And you can also get the original design I think they had from a company called 45 Drives. So the interesting thing is, as soon as you put that amount of spinning disks into a server and you have your initial cluster, you'll notice that your price point for object storage will be really low. And suddenly you start competing prices with global cloud providers, mind you. So compute nodes. On the Catalyst Cloud, we run generic Intel nodes, right? On some data centers, we have generic Intel. On our new data centers, we have open compute hardware. You don't need anything from a particular vendor. If you're happy with IBM, Dell, HP, whoever as your vendor, fantastic. But the reality is you're going to treat these guys as replaceable pizza boxes. So consider generic nodes. Why not? I think every vendor in this room will hate me after I leave the stage, but that's all good. I think it's part of it. Right, so someone said this morning, all the hypervisors, right? And the reality is, yes, OpenStack can run most hypervisors in the industry. You can run Hyper-V, you can run VMware. But the reality is, in the community, KVM is still by far the most widely adopted hypervisor. And actually, if you do the numbers, if you work your business case, you realize that the numbers don't stack up really well for proprietary hypervisors anymore, unless you have a special deal. But the deal locks you in another way. So open source hypervisors, great. KVM, Zen, great. But at least in terms of community support, I have found that we are better supported when we are talking to the OpenStack community about KVM, right? You're welcome to disagree. Especially if you work for Citrix. Now, node segmentation. This is an important one, right? So first I'll talk about node segmentation for financial reasons. Specialized object storage allows you to go high capacity, low cost. So you want to segment your nodes. With block storage, you have a different interest there. And for compute, you may want to have GPUs on your compute nodes. So while this whole idea of hyper-convergent infrastructure is really awesome and it works, we have started with a hyper-convergent infrastructure on the Catalyst Cloud in the beginning. As you grow, you will start specializing your nodes either for financial reasons or for technical reasons. And talking about technical reasons, the second part is about techniques that drive up quality and service levels. And I'll talk about node segmentation for technical reasons. We had kernel bugs affecting us in production. Where we had a compute node that was also a storage node. Well, since it's a compute node, you have a bunch of machines in there. The more machines you put, the more RAM you're using. But then on the storage side, we started reaching some kernel bugs where the high memory utilization was not leaving enough memory for shared memory for certain things used by Ceph, and then we started having some incidents there, right? And I'm talking about bleeding edge bugs that required us to go deep to the Linux kernel code, identify what was going on there, work with the Linux core developers, wait for a patch, do a workaround here, and actually fix the Linux kernel. So what you will find out is also that by isolating the roles of your nodes in your architecture, you tend to have less of those incidents. So there is a good reason for node segmentation. At least, I would suggest segment the control plane, compute, and storage. And if possible, segment your network nodes, right? That would be the bare minimum. Now, useful techniques if you're running OpenStack in production. You need to run CI and automated tests in your own cloud, right? In the beginning, you won't have a reasonable test infrastructure. So what we've done at Catalyst is to create a tenant inside OpenStack. That's where we run our CI. Every time we change a line of code in OpenStack, every time we change a line of code in our configuration management tools, the way we deploy OpenStack, we have an automated job that deploys a cloud inside our cloud, resembling the physical environment that we have, and runs a series of automated tests, OpenStack unit tests, integration tests, but we also run Tempest tests. So this is probably one of the most important tricks you will learn from this presentation. You guys are probably familiar with Tempest. Tempest is an OpenStack project that helps you to exercise OpenStack. And many people don't know that Tempest has got something called scenario tests. Scenario tests are exercising your cloud as customers would. It's spinning up a virtual machine, a compute instance, attaching some block storage, writing something, detaching, attaching somewhere else. Is the data there? Right? It's doing a series of operations just like your customers would do in real life. So why not putting this in your CI environment? And going further, what we've done at Catalyst is to actually use Tempest also as a form of monitoring. So we run Tempest in production in our regions, say every hour, to make sure that all projects are working as expected and we are not introducing regressions to our production environment. Now, pre-production environment, I have covered that. Another interesting one is, if you're a service provider interacting with lots of customers, I would suggest you to think in advance about communication channels with customers and have a plan on how you would communicate with them when things happen, right? So we found ourselves at Catalyst developing scripts that would allow us to point to a compute node, say, and find out all the virtual machines that were running there and who are the customers that own these virtual machines. So if we have to do planned maintenance or if an instance take that compute instance down, we can give them a call or send them an automated notification saying, hey guys, something happened to your computing, to one of our servers, we have migrated, evacuated your computing instances to another node. Not a live migration, that would be awesome, right? Server down and you do a live migration. I think Nectar has got something similar, because while working with Nectar in a project that we were doing together, I started getting some notifications saying, hey, there will be some planned maintenance and you're going to be affected. That's awesome. Now, another interesting one is when you're deploying OpenStack, you're using a configuration management system, right? If you're doing it seriously, you're automating your OpenStack deployment. It's not feasible to manage OpenStack without this. Now, if you're doing something that allows you to rack a server and say, this is a compute node, why not introducing that to your monitoring system at the same time, saying, now I need to monitor a compute node, now I need to monitor another storage node, right? So make sure that as you rack more servers, your monitoring tools are picking that up automatically and monitoring them. Now, in-place upgrades. So unfortunately, Sergey is not here. I was hoping he would be here. So I met with Sergey at LinuxConf, and he said, no, Bruno, I can't believe you. In-place upgrades don't exist in OpenStack. I said, Sergey, you know, we've been doing this for a while. Like, we've done a series of production upgrades, and some customers have not even noticed that they had a new version of OpenStack. No, not possible, not possible. Well, it turns out it is possible, right? So the important change there is that many OpenStack projects introduced a backward compatible API. So that allows you to upgrade one project at a time, and the projects that are running the previous version can interact with the projects that are running the new version. And that's great, because now you don't need to do a big bang anymore. And we had to do one of those, and it was painful, right? Now you can upgrade just Keystone, and then next week Nova. You know, you can choose the order that makes sense to you. But when you do so, make sure you can test every change in CI with your automated tests, and that you rehearse every move you're going to do in production, in pre-production first. And if possible, work on your live migration for compute instances. If you have a bulletproof live migration, and that's better now with Mitaka and the QEMU guest agent, that means you can actually, you know, move machines before taking a node down for an upgrade. It gives you some flexibility, right? We don't want to work 3 a.m. in the morning every day. And make sure you also have some scripts that allow you to do live migrations of compute instances, but also migrating routers, for example, between your different controller nodes, if there's where you have your layer 3 routing happening. Now, the last part of the presentation is common deployment mistakes. And the number one mistake, in my opinion, is OpenStack driven by graphical user interface. People have this idea that, you know, there are a bunch of distributions for OpenStack. I'll push a button and I get OpenStack deployed. This is true, but deploying OpenStack is not the hard part. The hard part is running a cloud environment. Look, a cloud is a complex distributed system with a lot of moving parts, interacting with your whole data center. And the ability to troubleshoot something that is happening there and go down sometimes even to the code level to find out what's going on and fix that incident in production is what matters. And I have seen no interface so far that allows your team to troubleshoot it. So, you know, don't cheat yourself thinking, hey, I have deployed OpenStack because I have used, I don't know, Juju, Fuel, whatever. You know, that's not the hard part, guys. Make sure you know the inside and out of OpenStack so you can manage it yourself, right? So people ask me deployment tools. You know, what are the best deployment tools? Hey, there are plenty of good Puppet, Ansible configuration manifests or playbooks maintained by the community, maintained by organizations that are running this in production. Packages, I think as the community, we are moving away from them. We're going towards, you know, containers or virtual environments. But packages still have their place in some nodes and for some of the components we're running there. Now, let me move on. Second biggest mistake in OpenStack landed. You carrying your own patches. Seriously. Never do this unless you have a very, very good reason to do so, right? Every patch that you don't commit upstream creates a recurring overhead on your team. And with a release every 6 months, you will need to rewrite that patch again and again and again. And as they grow, you won't be able to upgrade. I'm talking about companies like HP being stuck in production for many years without being able to upgrade their OpenStack cluster because they've done this. I'm talking about Rackspace throwing away maybe $1 million of code because, so be careful, right? Don't do it unless it's absolutely necessary. And the point is there will be a point where it's necessary. Just choose the right ones, right? Use this when you have no other resource available. Now, the cloud is on a hypervisor. No need to say this to you guys. But if you're going to OpenStack because you want a VM or hypervisor replacement, you're looking at the wrong thing, right? Check KVM. Check some of the tools around KVM that will allow you to manage it better. OpenStack is a cloud computing system, and it will do much more for you than a hypervisor does. Now, next one, Keystone. Keystone is not an IDP. So if you're deploying OpenStack to production, consider backing Keystone with OpenLDAP, Active Directory maybe, a SAML-based IDP. But don't use Keystone as your IDP if possible, right? On day one, maybe. But make sure you have a plan to go to a proper backend for Keystone. And think about people will create, terminate their accounts, and reset their passwords up front. Now, next mistake. All projects in OpenStack are production ready, right? A project exists, therefore I can do it in production and I'm good to go. Some people ask me, why you guys haven't deployed database as a service on the Catalyst Cloud till nowadays? And not many people have looked at the source code of Trove to the level we've done and found some security issues that haven't been patched yet, right? And the point is, not every project that exists in OpenStack land is ready for prime time. They may be ready for some vendors. They may be ready for some deployment methods, depending on how you're configuring them. But the point is, understand your requirements, validate the functional, and in particular, the non-functional requirements. Do I need HA? When I deploy this in production, will I be able to do HA? Do I have a backward compatible API? Can I do an upgrade when needed? And have a look at security standards, right? Some of the newer projects in OpenStack, they're learning how to do things, and sometimes what they're doing on day one is not very secure. So use your own judgment there. Now, finally, this is the part where I give you some gold. Do the numbers stack up? So, can OpenStack beat the prices of massive scale global cloud providers? And here are some maths. AWS in Sydney charges for an M3 large, M3 largest 2 virtual CPUs, 8 gigs of RAM, $136 per month. But you say, oh, Sydney is more expensive than the United States, so it's not fair to compare. Okay, so United States, $97 per month. But you say, oh, no, wait. But if I reserve my instance for 3 years and pay part of that up front, that's when I get my cheapest possible price from Amazon. So give me that. And I say, oh, cool, that's $38 per month, right? So how much would the equivalent of that virtual machine, that compute instance, cost in OpenStack? And the way I've done this calculation, I'm considering you employing 2 to 3 people in order to manage your OpenStack cluster, right? That's your OpenStack cost for that machine, $15. That's a $23 price difference, or 152%. But this price is only valid, this kind of cost, you will only reach the economies required here once you probably cross the point of having 1,000 virtual machines being managed by OpenStack, right? In the beginning, when your cluster has got only 1 virtual machine that is being paid for, and you're employing 3 people, yeah. So do the numbers stack up? Yes, they do. And I'm not surprised to see people like Dropbox moving to their own private infrastructure. I'm not surprised to see big telecom companies or even car manufacturing companies starting to use OpenStack. At the scale they are and with the amount of infrastructure they have, the numbers make perfect sense. Cool. I think that's what I had for you guys.
Excellent practical advice as usual, Bruno. Really, really loved the points there. I honestly couldn't say it better myself. And cool to see the cost analysis like this as well. When did you guys do this cost analysis?
This morning.
Excellent. on demand as
the
needed.
prices change. I just wanted to have the latest and greatest price from AWS in the comparison. That's all.
So excellent work by Catalyst IT, really fantastic. I will take some questions. Things in the meantime, which I really did want to highlight that are brilliant about this presentation. Tempest, very, very cool project. Check it out if you don't know about testing, because it is a really good way to make sure your OpenStack cloud actually works. It's also backed by DEFCOR, and DEFCOR is a committee across OpenStack which is trying to make sure that the right tests are in place for these things. Also, upstream training. The OpenStack's just released a new upstream training for being able to make sure you're not losing money by having that all in there. So make sure you check out that. Questions for Bruno? Yes, we'll take one question down here.
So if you have like a urgent patch, what do you do? Do you wait from the upstream?
So the first thing you do is either you work on a bug or a blueprint upstream. You make sure that that code is committed upstream. Once it lands in OpenStack and it's merged, you can backport that patch and even apply it to an older version of OpenStack that you may be running in production, right? You're probably 6 months away from master here. Once it's merged, it's relatively safe for you to backport that patch and use it. But if it's not merged upstream and you start running that in production, good luck.
And look, upstream is really, really important because it's difficult to get started. As per usual, most OpenStack communities have a pretty big learning curve. We're trying to make that easier, but it's definitely worth talking to Catalyst IT about how to get engaged in that.
By the way, besides me, we have Andrew Bogue from Catalyst.
Andrew says hi. Andrew and Bruno, where are you guys based during the event? Do you have a booth or a place you're hanging out?
No, we don't. We're here.
Right here?
We haven't. Yeah,
or at the pub afterwards. I know Andrew and I are.
Sure.
It's great to have a beer with these guys.
Andrew is based in Sydney. He's just 5 minutes walking from here. And if you guys want to have an honest discussion about OpenStack, we're happy to talk and provide some guidance.
Where are we having beers after this then, Andrew? What's the best place? Right there, right upstairs. Okay, we're doing the switchover dance. Let's give Bruno another round of applause.